Welcome to clickmyprojects.com. Here we discuss about application of a growing self-organizing map to distinguish between finger tapping and non-tapping from brain images. Segmentation is the process that groups similar objects together and forms clusters. Thus, it is often referred to as clustering. Clustering groups are homogeneous within, desirably heterogeneous in between. The rationale of intra-group homogeneity is that objects with similar attributes are likely to respond somewhat similarly to a given action. This property has various uses both in business and in scientific research. Most clustering techniques are developed for laboratory-generated data clustering of a few to several numerical values. Self-organization map, also known as coherent feature maps, were developed to simulate the ways that vision system works in our brain. Image segmentation is used to locate objects and boundaries in images. More previous, image segmentation is the process of assigning a label to every pixel in an image, such that pixels with the same label share certain visual characteristics. The result of image segmentation is a set of segments that collectively cover the entire image, or a set of contours extracted from the image. Each of the pixels in a range are similar with respect to some characteristics or computed property such as color, intensity, or texture. Adjacent regions are significantly different from with respect to the same characteristics. In the clustering-based segmentation, the distance in the squared or absolute difference between a pixel and a cluster center. The difference is typically based on pixel color, intensity, texture, and location, or a weighted combination of these factors. Here, these sectors can be selected manually or randomly or any automation method. This segmentation is processed by the help of clustering in an image. Self-organizing map is a type of artificial neural network that is trained using unsupervised learning to produce a low-dimensional discretized representation of the input space of the trained samples called a map. Self-organization maps are different from other artificial neural networks in the sense that they use a neighborhood function to preserve the topological properties of the input space. Thus, in our paper, we use the SOM segmentation algorithm for brain image segmentation. Here, we are using the SOM characteristics to form the clusters of images by using SOM characteristics, and finally we segment these cluster formation. We get the segmented result of given MRI images. Here we separate the MRI images in gray matter, white matter, and other brain tissues like tumor spot, etc. Here this algorithm gives the better result than any other algorithm in segmentation process. This is the flow diagram of our project. In the first step, we initialize the given image. In this initialization stage, we extract the image and we convert the 3 sample images into single sample image. That is, we convert RGB color space into grayscale image. Then we estimate the size of the given image, and finally we reconstruct the image into required size to extract the clustering sizes known to meet the segmentation process. Since in the initialization stage we provide noise removals and image enhancement. After that, the enhanced image was given to cluster formation regions. In this, it gives the k nearest neighbor structure to extract the cluster formation for the given images. After the formation of clusters, we extract the features of each and every clusters which are found in the image pixels. Here the clusters was formed by the threshold differences of each and every pixels which are found which are matching the given threshold values. After the formation of clusters, The feature values are extracted, and finally these are given to SOM segmentation. In this SOM segmentation, it gets the cluster information, and finally it separates the each and every clusters, and finally it gives the label for each and every cluster formation. This was done by a network formatter in the SOM segmentation. The labels are given to each and every pixels in the given image. The label was done by the cluster formation, which are done in SOM segmentation mainly by using the neural network formation of SOM characters. These labeled images are set as in a matrix formation. Then after that, the labeled images were separated, and each and every labels are separated in a variables and stored in a separate matrix. Then for that each and every labels, we use the color representation to give colorful segmented output. Now I am going to explain the running process of our project. Now just run som main.m file. Here it gets the input from user. Now you select any image which we want to segment. Here in the first stage it gives the input image display. After that it provides the SOM segmentation formation by using the cluster formation from the given images. Here the figure in this displays the segmentation output. This displays the segmented images which are given to cluster indexes. We can see the cluster formation by selecting the data cursor icon. You can see the each and every labeled images, this representing the color formation. The RGB value 001 represents the blue color, and the RGB value 010 represents green channel of the image. Then the RGB value 000 represents the black color, and the RGB value 100 represents the red color of the image. Then here the RGB value 110 represents the yellow color of the segmented result. By using this we can use the color labels for each and every labeled images. We can see the labeled images by displaying the segmented output as here. This output gives the segmented output. Then each and every labels gives the indexes gives the labeled segmented output. This is the segmented result from SOM segmentation. From this image we gives the color labels for each and every index value. Finally we gets the color output result. Thus we provide the segmentation by using SOM segmentation algorithm and MRI brain images. Thank you.